Sentinel-1 is always ready.
Sentinel-1 is a Swiss Army knife. It's such a multifaceted tool that can be used in a whole variety of different areas, and I think that's what makes it so special.
Whatever corner of the world you want to look at, you know already that the Sentinel-1 has already taken this image.
Sentinels 1A and 1B and C and D now were designed as a series.
Sentinel-1A was the first launched satellite in the family of the Copernicus fleet in April 2014, and it was followed only 2 years after by Sentinel-1B in April 2016.
It's a unique satellite because it's an all-weather imaging satellite and it employs a radar.
What we call a synthetic aperture radar.
And the radar can penetrate through clouds.
It can be operational, it can be observing day and night.
Because the instrument is illuminating the surface in order to produce an image.
And particularly if we look at the dark areas, for instance the Arctic, where we have like nighttime half of the year, we can still use Sentinel-1 data.
Traditionally, a satellite that is looking at the environment is taking images.
So this radar image, which is at C-band, which is a particular wavelength that allows us to penetrate through storms and clouds, allows us to make images and a stripe of images around the globe.
But something that the Sentinel-1 brought into the Copernicus program was the possibility of doing what we call a continuous mapping. Think about a painter with a brush, and then this is what we're doing. It is a continuous painting.
The idea of having two satellites in orbit around the globe is that we can halve the interval of time between images. We can provide global coverage at much more regular intervals.
With a two-satellite constellation, we can do this in 6 days, and that enables a better coverage for sure. So a better revisit allows a closer monitoring of changes in the land cover.
Sentinel-1 instrument gives a resolution of 5 by 20 meters. What is the most important challenge of continuation of the Sentinel-1 mission? The most important challenge that we have with respect to the Sentinel-1 mission is to adapt the continuity of the mission to the new user requirements.
Sentinel-1 mission focuses on reliability, operational stability, global coverage and quick data delivery, and Sentinel-1 Next Generation will do the same in the future.
Users are starting to ask for more resolution, and this is what we will respond with the Next Generation.
Sentinel-1 has been brilliant, particularly in terms of enhanced continuity. The higher resolution of Sentinel-1 Next Generation is the most important thing to say here.
It's a fantastic tool because it provides all-weather data and we can address a number of different topics.
Oil spills, marine winds, waves and currents, ship and vessel tracking.
It's providing fantastic information products at high latitudes.
Deformation in urban areas due, for instance, to groundwater extraction. Also deformation of volcanoes, landslides or in permafrost areas, which is very relevant for climate change.
We can provide information about ice cover in the polar oceans.
Sentinel-1 radar images are particularly suited to generate high-resolution ice charts, to distinguish between thin ice and multi-year thicker ice, to monitor icebergs and to forecasting ice conditions. If you want to navigate ships through the sea ice, you need to understand what kind of ice it is.
It enables us to map crops at field scale. It also enables us to map how much water is in the soil, so soil moisture.
And agriculture, which is for sure related to monitoring soil moisture, and deforestation, for instance, in the tropics, and hurricanes. So a very important application is also SAR interferometry, where we use data that were acquired on the same place on Earth, but in different orbit overflies. So with the two satellite constellation, we get data every 6 days. And if you, for instance, have like an earthquake happening along a fault line, and we have like a display displacement of centimeter level, we can take the phase distance of the two satellite acquisitions and we can map the deformation over several years to monitor millimeter displacements of the ground surface. 75% of natural disasters that occur worldwide involve flooding. The inherent capability of SAR to observe during cloud cover and Sentinel-1's frequent revisit makes it ideal for flood monitoring. It can be used to assess the extent of flooded areas and the impact on human, economic and environmental loss.
That will tell you which roads you can use for the lorries to bring the first aid.
This is a fantastic multi-dimensional tool that can be used in a variety of services, and I think that's what makes it so unique.
The development of the Sentinel-1 spacecraft was led by Thales Alenia Space in Rome, but with the important contribution of Airbus. And this technology was developed in Europe. There was the effort of the different companies to develop technology that it is also bringing Europe in a leadership position with respect to that. It is important to mention this because what we are talking is about the two most important competitors in the space business in Europe. And Sentinel-1 managed to put them together. We have more than 65 companies all across Europe that they are contributing in a way or another in this mission. I believe that the most vital and significant contribution of the Sentinels is what we call commitment. We are committed to maintain the services for this decade and for the next decades to keep giving continuity to this mission.
And the most important, we are covering so many different applications and so many different services, and the users are very happy with the data.